The lights in this factory have not been switched on in over 3 years, not because it shut down, because it never needed them. Inside, robotic arms move through absolute darkness, picking, welding, and assembling at a pace no human shift could match. No coffee breaks, no safety lighting, no shift changes at 6 a.m. The facility is called the Mid-Air Smart Manufacturing Complex. It sits in Shunde, Guangdong province. It cost $1.2 billion to build, and from the outside, at any hour of the day or night, it is completely dark. China has been building facilities like this since 2015. By the early 2020s, the Ministry of Industry and Information Technology had certified hundreds of sites meeting its smart manufacturing benchmark, a program expanding faster than any comparable initiative in Germany, Japan, or the United States. What nobody has explained is why China needed them to scale this fast. This is Project Scale. Subscribe and drop a comment. What do you want us to cover next? If you manufacture anything, or if your job depends on a company that does, this type of facility is already competing with your supply chain. The Fanuc Corporation plant in Oshino, Japan has run lights out since 2001. Engineers there considered it a proof of concept for future decades. China looked at that model and decided the future was now, not in one factory. In dozens, then hundreds, then a national program with a name and a budget line. The problem China was solving had a specific deadline attached to it. By 2021, Chinese manufacturing wages had risen approximately 300% over 15 years, according to the National Bureau of Statistics of China. The cost advantage that built the world's factory floor was compressing. The math that had made China the manufacturing capital of the world for 40 years was starting to fail. Government planners formalized the response in a document released on May 19, 2015. Made in China 2025, authored by the State Council in consultation with the Chinese Academy of Engineering, set numerical targets that most Western economists publicly dismissed as politically optimistic at the time. 3 numbers explain what happened next. China installed 290,258 industrial robots in 2022 alone, more than every other country in the world combined, according to the International Federation of Robotics 2023 World Robotics Report. That is the equivalent of deploying 1 fully operational robot for every worker currently employed in the city of Pittsburgh in a single calendar year. The Chang'an Precision Technology Facility in Dongguan, a smaller predecessor to the Midea complex, reduced its human workforce from 650 employees to 60, while reporting a 3-fold increase in output. The 60 remaining workers do not operate machines. They monitor the systems that operate the machines. And then there is Germany. Volkswagen converted its Zwickau plant to full electric vehicle production starting in 2018. It opened in late 2019. It cost around 1.2 billion euros. It employs approximately 8,000 people on the production floor today. Dongguan, 60 people. Zwickau, 8,000 people. Same category of facility, same approximate cost range. The difference in that headcount number is not an accident of ambition or technology. It is the result of a decision made at a policy level a decade earlier, and to understand what that decision actually was, you need to go back to the moment it happened. The precise moment China's automation strategy shifted from aspiration to mandate can be traced to that 2015 document. Made in China 2025 set a robot density target that seemed at the time disconnected from reality. Chinese manufacturers were to achieve 150 robots per 10,000 workers by 2020. In 2015, the figure stood at 36. The goal required quadrupling robot density in 5 years. They hit 246 by 2022. They passed their own target by 64%. The counterintuitive decision inside that policy was not the automation target itself. It was the instruction to build the robots domestically rather than continue importing them. China was, at the time, the world's largest buyer of industrial robots from KUKA, a German manufacturer founded in Augsburg in 1898, widely regarded as one of the 3 best robotics companies on the planet. In 2016, Chinese appliance maker Midea Group acquired KUKA outright for 4.5 billion euros. a company whose primary product was air conditioners, had just purchased one of the most sophisticated robotics manufacturers in the world. The technology transfer that might have taken 20 years through gradual licensing agreements happened in a single transaction. At the time of the deal, financial analysts questioned whether Midea understood what it had bought. The Wall Street Journal, Reuters, and Bloomberg all covered the acquisition with notable skepticism. A Chinese appliance manufacturer owning German precision robotics seemed, on the surface, like a category error. The answer to that skepticism became clear over the following 7 years. By 2023, Chinese-manufactured robots, primarily from domestic firms Estune, Xiaomi, and Innovance, held roughly 36% of the Chinese domestic market. In 2015, before the KUKA acquisition reshaped the competitive landscape, that figure was under 10%. The lights-out factory concept did not originate in China. The decision to deploy it at the scale of a national infrastructure program did. Stand at the entrance of the Chang'an facility in Dongguan at midnight, and the first thing you register is the sound. Not silence, machinery. But the kind of machinery that makes no accommodation for human presence. No warning beeps at corridor intersections. No emergency lighting strips along the floor. The automated guided vehicles navigating the production floor do not produce visible light. They run on LiDAR and millimeter-wave radar, locating themselves and each other in complete darkness with sub-centimeter precision. A correspondent for MIT Technology Review who toured a comparable Midea lights-out facility described the experience this way. The disorienting part was not the darkness itself. It was the sound of machines moving around you without registering that you were there. The systems did not slow down or reroute for a human standing in the space. The human was an obstacle in a system not designed to have obstacles. That observation from an outside reporter, not a company press release, captures something that production statistics cannot. The facility operates across multiple zones. The machining area handles raw CNC operations. Metal blanks enter one end shaped like rough cylinders, and precision components exit the other. The entire sequence runs without a human hand touching the material. Think of it like a postal sorting system, but each item weighs 4 kilograms and arrives in the wrong shape. The precision assembly zone works at tolerances measured in microns, millionths of a meter. This is where lights-out manufacturing makes its clearest quality argument. A human hand, regardless of training, introduces variability at this scale. Robotic actuators guided by optical feedback do not. Every finished component passes through three-dimensional optical scanning. Defect detection rates at facilities using this approach run significantly higher than conventional human visual inspection, according to benchmarks published by China's Ministry of Industry and Information Technology. The architecture that makes the facility resilient is the edge computing layer. Each robotic system carries its own local processing, running independently of any central server. The factory does not depend on a continuous network connection to function. A network outage does not stop the floor. That solved the single point of failure problem that had undermined earlier automation attempts. It created a different one nobody had anticipated. When dozens of independent autonomous systems make routing and sequencing decisions simultaneously in close physical proximity, they develop conflicts the original programming did not account for. Two systems reach the same intersection from different directions. A finished component is needed in two places at once. The Chang'an operations team spent over a year of live production developing conflict resolution logic, not in a laboratory, but by watching what the deployed systems actually did and writing rules around the behavior they observed. The factory debugged itself by running. On September 22, 2015, the Chang'an facility completed its first full lights-out production cycle. Continuous operation with 0 human operators on the floor. The reported defect rate was 0.01%. At a human-operated facility of similar scale and product type, defect rates typically run between 1.5% and 3%, depending on component category, according to benchmarks from the American Society for Quality. That gap, measured in fractions of a percent, compounds across production volumes of millions of units into a cost difference that shows up in contract negotiations. Engineering publications noted the Chang'an result not as a novelty, but as a template. The facility reached full capacity in under a year, a commissioning timeline that European industrial planners, accustomed to multi-year ramp-up periods, found difficult to account for in their competitive models. But Chang'e was not the destination. It was the proof of concept run. What China tested in Dongguan in 2015 became the construction blueprint for the Midea complex in Shunda, the $1.2 billion facility named in this video's title. Shunda operates at a scale that makes Chang'e look like an early prototype. It is the facility the Ministry of Industry and Information Technology points to when other countries ask what a national smart manufacturing benchmark actually looks like at full deployment. Here is what almost no Western coverage of China's automation push actually examines. In 2018, a mid-sized automotive components manufacturer in Baden-Württemberg, Germany, began the approval process for a new, fully automated production facility near Stuttgart. The company had the capital. It had selected the equipment suppliers. It had identified the site. By 2023, 5 years later, construction had not started. The facility was still working through environmental impact assessment, 2 rounds of zoning review, union consultation required under German co-determination law, and grid connection authorization from a regional utility. Every stage involved a different regulatory body. Every stage had its own timeline. None of them ran in parallel. This is not a story about German incompetence. Germany has the engineers. Germany builds better robots than China currently imports. What Germany has is a governance structure built around a different set of priorities: labor rights, environmental review, democratic accountability, that were designed before lights-out manufacturing existed as a concept. The approval process was not built for a factory that has no workers and runs at 3 a.m. China's designated smart manufacturing zones operate under a different architecture. Local government approvals, national ministry certification, and construction proceed simultaneously. The result is a land-to-first production timeline that runs between 2 and 3 years in designated zones, compared to 5 to 10 years in the European equivalent, even under favorable conditions. The gap is not technology. The gap is the calendar. This is the asymmetry that Western manufacturing executives are now trying to explain to their boards. It is not why they lost the technology race, but why a race that runs on approval timelines is one they have no structural mechanism to win at current speed. Here is the number that stops people mid-sentence. A lights-out facility running at full capacity can match or exceed the output of 2,000 manual workers, running 24 hours a day, 365 days a year, with no sick days, no shift premiums, no turnover, and no pandemic risk. The energy cost per unit runs lower than a conventionally operated facility of equivalent size, because heating, lighting, and human comfort infrastructure is removed entirely. Send that to someone who works in manufacturing. Watch what happens to the conversation. 3 things look different now than they did 15 minutes ago. The first, the phrase "made in China," no longer describes a labor cost strategy. It increasingly describes a production architecture, one where the question is not how many workers are on the floor, but whether there are any workers on the floor at all. The second, the competition between Eastern and Western manufacturing, is not a technology race. Western nations have the robotics capability. Germany built KUKA. Japan built FANUC. The United States has the capital markets to fund deployment at scale. What none of them has is a regulatory and governance framework designed to approve and build these facilities at the speed the technology now allows. That is a harder problem to solve than building a better robot arm. The third, China did not build lights-out factories to replace workers. It built them to remove the category of risk that workers represent: illness, wage pressure, turnover, labor disputes, pandemics. The factory that cannot be disrupted by a human decision is a strategically different asset from one that can. By 2030, China's Ministry of Industry and Information Technology has projected that the majority of large-scale facilities in its designated smart manufacturing zones will meet lights-out certification standards. The Sichuan corridor, which includes aerospace and precision components manufacturing, is a priority transition target within that timeline. The engineers who designed Chang'e in 2014 have long since moved to the next project. Several of those projects involve not just autonomous production, but autonomous process optimization. These are systems that observe their own output data and reconfigure assembly sequences without human instruction. That category of facility does not yet have a standard name in English. The question worth sitting with is not whether automated manufacturing will spread. The trajectory is not in question. The question is what the global economy looks like when the competitive variable is no longer the cost of the worker, but the cost and speed of building the system that replaced them, and how long it takes your government to approve the building permit. If China's factory automation caught you off guard, wait until you see what they built to power it. A transmission network moving electricity across 5,000 kilometers at voltages no country had achieved at commercial scale before 2019. That one is next.